Our final lesson in the right triangle unit is probably my favorite. And I have to admit it's my favorite because it involves word problems, so real life applications. I know those are your favorite because you all love word problems. Our essential question for today, how do I find angles of elevation and depression? Now, we are going to be using trigonometry, so take a minute, make sure that your calculator is in degree mode. Okay, two critical vocabulary words here, angle of elevation and angle of depression. So what is the angle of elevation? When you are looking up to an object, the angle of elevation is formed by your line of sight, so where your eyes are going, and a horizontal. Notice that we have to make a right triangle here. Okay. The angle of depression happens when you are looking down. The angle of depression is formed between your line of sight and a horizontal line. Now notice that your horizontal line goes straight out from your eyes, okay, and the line of sight is going down. The angle of depression is congruent to the angle of elevation because they are alternate interior angles. Let's look at this here. Horizontal line, horizontal line. By definition, all horizontal lines are parallel to each other. There's my transversal, transversal to parallel, transversal to parallel. My angle of depression up here is the same as my angle of elevation down here. Pretty cool that Unit 3 comes into play, don't you think? Alrighty, now let's practice. The angle of elevation from a kicker's foot on the football field to the top of the goalpost. All right, so here's my football, and here's my goalpost. From here to here, they're telling me the angle of elevation is 17 degrees, and he is standing 131. Whoa, guess I drew that a little weird. Let's try this way. We'll make a more simple goalpost. There we go. To the top of our goalpost. And we are standing 131 feet away from the base of the goalpost. How tall is it? So let's label these. This is my angle. So this is opposite. And this side is adjacent. So ka, toa. Opposite and adjacent is tangent. Tangent of 17 degrees equals x over 131. Need to apply a little algebra here to isolate the variable. Multiply both sides by 131. And then we are going to use our calculator. 131 tangent 17. 40.051 feet. There are units in this problem. There should be units in your answer. A pilot in a helicopter spots a landing pad below. So, don't you love my drawing skills? There's my helicopter. And here's my landing pad. I am told the angle of depression, so I need a horizontal. And there's my angle of depression, 73 degrees. And of course, we turn this into a right triangle. The horizontal distance, that would be across, is 1,200 feet. What is my altitude or my height of my helicopter? Let's see. Identify these. Here's my angle. So this is opposite. This is adjacent. I'm using tangent again. Opposite over adjacent. Tangent of 73 degrees equals x over 1,200. Multiply both sides by 1,200. X equals 1,200. Tangent of 73 degrees. Let's see. So this helicopter is 3,925.023 feet high. Building A is 480 feet tall. Building B is 654 feet tall. If the angle of depression, okay, it means I need a horizontal. My depression is 42 degrees. How far apart are the buildings? I should have made that land right on the corner. Let's see if I can do a better job here. There we go. Okay, well, first off, I want to know how far apart are the buildings, right? I also need to know this distance. There's a difference in the heights. So 654 minus 480, this piece of the triangle is 174 feet. I have opposite and adjacent again. And before you ask, no, they are not all tangent. That just happens to be the first three example problems I picked. Tangent of 42 degrees equals 174 over x. All right, I need x on top. It cannot be on the bottom of a fraction. So x times tangent of 42 degrees equals 174. Now to get tangent on the other side so that x is all by itself, I will divide by tangent of 42 degrees, and x equals 174 divided by tangent of 42 degrees. So let's see. 174 divided by tangent 42. This is 193.247 feet. Yes, feet apart. Not quite 200 feet apart. Sometimes you have to stop and think about the information you're given in the problem, right? I was given enough information to solve this, but I did have to do a little subtraction in order to find the opposite side of my triangle. Okay, Sam sights the top of an 84-foot tall lighthouse. At an angle of elevation of 58 degrees. If Sam is 6 feet tall, how far is he standing? So remember, we come from Sam's eyeballs, and we're going to assume his eyeballs are at 6 foot. I know, but that's what you assume. Angle of elevation. And let's see, that's 58 degrees, right? Okay, so if Sam is 6 foot tall, this little piece of our lighthouse right here is 6 foot tall, and 84 minus 6, this side of my triangle is 78 feet. Not drawn to scale, but that's okay. How far is he standing? Yet another tangent example. However, on your homework, you definitely have sine and cosine problems. So don't think they're all tangent. They are not. All right, tangent of 58 degrees will equal my opposite over my adjacent. 78 over x. I need x on top of the fraction, so I'm multiplying both sides by x. X times tangent of 58 degrees equals 78. Now I need to isolate x, so I divide both sides by tangent of 58 degrees. And x equals 78 divided by tangent 58 degrees. So let's see, 78 divided by tangent 58, and I get 48.740 feet. Watch your rounding on that one. That one was tricky. All right, take a minute to write your summary of this lesson.